Look up at the night sky. Everything you see, every star, every galaxy, every cluster, is finite. They have a beginning, an end, and a manageable size. Now, forget everything you think you know about scale. Imagine a single object, so impossibly vast, so astronomically heavy, that its shadow alone could swallow 20 of our solar system's whole. This is not a hypothetical nightmare. This object exists. It sits over 10 billion light-years away, and it is known, rather modestly, as TUN 618, abbreviation of Tenochtitlan 618. TUN 618 is a black hole, but it is not a stellar black hole, the kind born from a supernova, a mere few dozen times the mass of our sun. It is an ultra-massive black hole, and it is the single largest black hole ever measured, weighing in at an estimated 66 billion solar masses. To grasp this, our entire solar system is tiny. The nearest star, Proxima Centauri, is 4 light-years away. If TUN 618 sat where our sun is, its event horizon, the point of no return, would stretch far beyond Neptune, past the Kuiper Belt, and potentially even consume the Oort cloud. It is a cosmic anomaly, a violation of scale, and its very existence challenges the foundational limits of astrophysics. How do you find a black hole that is, by definition, invisible and sits 10.4 billion light-years away? The answer is simple. You don't look for the black hole itself. You look for its scream. The first whisper of TUN 618 came in the 1950s, not from powerful visible light telescopes, but from surveys looking for faint blue starlight. Astronomers labeled it simply as Tohoku Observatory Notice 618. It appeared, at first, to be a faint blue star in the constellation Canes Venatici. It wasn't a star. In the late 1960s, radio astronomy revealed its true nature: a quasar. A quasar is the most energetic object in the known universe, powered by the feeding frenzy of a supermassive black hole. The material circling the black hole, the accretion disk, is heated by friction to trillions of degrees, blazing with light 100 times brighter than the entire Milky Way. When astronomers focused the telescopes, they weren't seeing a tiny star. They were seeing a lighthouse of unimaginable power, billions of light-years away. But the light wasn't the biggest shock. The size of the quasar's engine was. The primary method of weighing this colossal engine relies on analyzing the light emitted by the surrounding gas. Specifically, scientists look at the width of certain spectral emission lines, like the magnesium-2 line. The faster the gas is swirling around the black hole, the wider these lines appear due to the Doppler shift. For almost every known quasar, these lines are narrow. For TUN 618, they were impossibly wide. This immense broadening indicated that the gas was moving at speeds so high, it could only be orbiting an object of truly monumental, unprecedented mass. The central mystery of TUN 618 is not just that it's big, but how did it get so big so fast? Standard astrophysical theory, specifically the Eddington limit, dictates the maximum rate at which a black hole can feed. When a black hole pulls in matter, the resulting heat and radiation exert a powerful outward pressure. Once the infalling matter reaches a certain rate, the outward pressure becomes so strong it blows the remaining matter away. This self-regulating mechanism limits growth. TUN 618 exists in the early universe, meaning it was already fully formed and massively overweight only about 3 billion years after the Big Bang. If it grew strictly following the Eddington limit, starting from a small seed black hole, it simply did not have enough time to reach 66 billion solar masses. Calculations show that even if it fed continuously at the absolute maximum allowed rate, it would still fall short of its current measured size. This mass anomaly forces physicists to consider two revolutionary possibilities. 1. Super Eddington feeding. Ton 618 must have somehow bypassed the Eddington limit for sustained periods, perhaps by feeding on dense, cold gas streams that exert less outward radiation pressure. 2. Seed size. Perhaps the seed black holes in the early universe weren't small at all. They might have formed through the direct collapse of massive gas clouds, creating seed black holes up to 100,000 times the mass of the Sun instantly, giving Ton 618 a significant head start. Both theories shatter our traditional understanding of cosmic evolution, suggesting the existence of a whole new class of cosmic beasts. What would the immediate environment around this ultra-massive black hole look like? While the event horizon itself is dark, the quasar, the accretion disk, and jets is terrifyingly bright. The luminosity of Ton 618 is estimated to be over 4 times 10 to the 40th power watts, making it one of the brightest objects in the visible universe. If you could somehow survive proximity to it, the light would be overwhelmingly blinding, a cosmic beacon of destruction. The immense mass of Ton 618 actually makes the immediate approach safer than approaching a small stellar black hole. The difference in gravity between your head and your feet are what rip objects apart, spaghettification. For a small black hole, these forces are intense right at the event horizon. But for an ultramassive black hole like Ton 618, the event horizon is so vast and the gravity gradient so gentle that an object could cross the boundary without any immediate physical discomfort. You would simply slip across the point of no return, unaware that you had just left the universe, pulled by a gentle, irresistible gradient of doom. The true danger is not the event horizon, but the quasar wind. The extreme radiation and energy generated by the feeding process create powerful outflows of high-velocity plasma and particles, a wind blowing out from the center. This wind is so forceful that it can effectively strip entire galaxies of their gas, halting all star formation and rendering the surrounding region utterly barren. Ton 618 is not just a singularity. It is a cosmic sterilizer. It is actively shaping the evolution of its entire neighborhood. Beyond the event horizon and the quasar, the terrifying influence of Ton 618 stretches across vast distances. Every galaxy has a sphere of influence, but for Ton 618, that sphere is gargantuan. Consider the mass of the black hole relative to its host galaxy. In most galaxies, the central black hole makes up a tiny fraction of the total galactic mass. For an ultramassive entity like Ton 618, this ratio is far more extreme. The question is whether the black hole built the galaxy, or the galaxy built the black hole. The existence of such a colossal object suggests an intimate and complex relationship with its dark matter halo. Black holes and dark matter halos grow together, influencing each other's evolution. Ton 618's sheer size implies it sits within one of the largest and most dense dark matter halos in the early universe, suggesting it formed at the absolute center of a supercluster, a galactic metropolis, that was destined for an extreme fate. It is the gravitational king of an entire region of space, far beyond its immediate host galaxy. The ultimate goal of modern astronomy is to capture a direct image of its shadow, similar to the Event Horizon Telescope's famous image of M87 star. However, TUN 618's extreme distance makes this almost impossible with current technology. Instead, scientists rely on gravitational lensing and subtle distortions in spacetime caused by the massive object. These indirect measurements confirm its size, giving us a mathematical truth about the most massive object we may ever encounter. We are measuring the mass of a ghost, 10 billion light-years away, using the ripples it leaves in the fabric of reality. What is the ultimate fate of TUN 618? While the universe is expanding, the black hole itself will continue to grow, albeit slowly, by absorbing passing stars, gas, and merging with other black holes. But the true end comes billions and trillions of years in the future, through Hawking radiation. This theoretical process dictates that black holes slowly leak energy over cosmic timescales. A stellar mass black hole might evaporate in 10 to the 67th power years. But for a monster like TUN 618, the estimated evaporation time is a staggering 10 to the 100th power years. A 1 followed by 100 zeros, or 1 Google years. To put that into perspective, the current age of the universe is a mere 10 billion years, when the last stars have burned out, when galaxies have faded, and when the universe is cold and dark. The 66 billion solar mass ghost of TUN 618 will still be there, radiating its final, feeble heat. It is a relic destined to witness the heat death of the universe itself. TUN 618 remains the cosmic anomaly, the object that defines the extreme edge of our physical laws. It asks the deepest questions. What were the conditions of the very early universe that allowed such rapid, prodigious growth? Did it cheat physics? Or do we fundamentally misunderstand the birth of these cosmic giants? It is the most powerful engine of destruction in the cosmos, a shadow of scale that should not exist, yet does. And it serves as a powerful reminder that in the cold, dark void, the universe still holds terrors far greater than we can comfortably comprehend. If you want to join us in turning the greatest paradoxes into scientific truth, then subscribe. We are dedicated to exploring the secrets of our world that defy easy explanation, and you won't want to miss what we uncover next. Veil Origins: Impossible Truths.